Okay, so we'll continue. This is some new topic, hash function and hash table. Probably this course will have more fun. It's more like not much of code, mainly for story talking. Okay, so okay, yeah. What's hash function? So hash function is a function that takes the input or key and returns a fixed size of string of bytes. The output is typically called the hash value, hash code, or digest. Okay, so this can be the string, can be a number actually. Okay, can be a number actually. So for example, yeah, I think we can discuss more detail later. Okay, yeah. Yeah, for example, very simple example here. We're using the mode. Okay, very simple. Mode can be a hash function. Okay, so any value, right? Any input, you process a mode. For example, mode 10, you can get the fixed size of output. Okay, within the 0 to 9. All right. So this can be using one hash function. For example, input 25, we finish is 5. 44 is 4. 97 will be 7. 17 will be 7. 10 will be 0. Okay, so this is one type of hash function. Simple as a hash function, we can see. Also, there's more complicated hash function. Okay, we're using a lot like the cryptographic, right? And for example, SHA 256. This is the most being used for encrypt. Okay, encrypt. For example, this is the input. This is after the hash function SHA 256. What the output is. Okay, this is a 64 character of the hexadecimal string. All right. So even though this, for example, this string 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 7 have a little bit differences, but after the hash function, the value is entire different. So it means you can't. It's hard, even though you got these two values, you won't be think the input is very similar. Okay, so some notes here. Even though a tiny change in output leads to entire different of hashing, right? Output always fixed length. Okay, fixed length. 64 hex characters, 258 bits, regardless of the input size. Some properties of the good hash function. Deterministic. First, deterministic. So same input always gives the same output. Okay, doesn't matter. Same input always gives same output. Uniform distribution. Hash value should be spread evenly. Even though the input are very similar, as we said in the previous example, very similar, but the output is different. Okay. Efficiency, right? So for the faster compute, very fast compute, you cannot take maybe a minute or 30 seconds try to calculate the hash, right? That's not applicable. Minimize the collision. So fewer key mapped to the same index. It means the collision means we'll discuss more detail regarding the hash collision. It means a different input, okay, but come out after hashing, the same output. Okay, that's called a collision. All right, okay. Also, I want to emphasize one thing, like for hash function, it's sort of invertible. Okay, so it's easy to calculate, but to give you a hash code, give you the value, it's hard to invert back into the input. Okay, so that's the purpose here. We give you a value, we give you a hash code, you can fast to calculate, give you input, you can fast to calculate the output. You can You can hard to decode, but easy to verify. Okay, that's the purpose, okay, for hash function. Okay, let's see how the hash function is used. I just grabbed some of the example. Okay, it's from ChatGPT and something, but let's discuss. Okay, there's more being using very widely now, and let's look at some of the common example we have. Hash table. Okay, so the hash table or hash map to effectively store and retrieve the data. So they have the implementation. They have the built-in function actually for in the lot of common programming language, like in dictionary, right? In Python, hash map, like in Java, right? Have a symbol table using symbol tables in the compilers because it's very fast to retrieve the data, to make the entire compile process faster, right? Using cache and lookup tables. So for cache, the purpose for cache is mainly to temporary store and to fetch and reuse it right away, right? So that's for cache. So the hash table has matched its purpose. Why? Because they give the constant complexity. It's big one, okay? Big O of one. So it's extremely fast. We learn about the linear structure, right? And we learn about the tree. And for hash table, so the perfect hash table gives the big O of 1 time complexity if you want to retrieve all the data. So they have an insert, search, and delay. You have big O of 1. Okay, so leveraging the hash function, we create a hash table, and we can get this feature work. So that's why been using a lot. Okay, been using a lot. For example, if we store the students, right? For example, Alex, we have the Maddie and Bob 85. So this is the mark we have. When we do the retrieval, if we want to leverage the hash table, what we do here? For example, we treat Alex and Bob as a key, okay, as a key. And we can process the hash function for Alex map to index in array, okay? And Bob, and then when Maddie is stored there, and Bob will use the same hash function map to another index. So for array to access, if we know index of the array, we can access elements, right, based on constant big O complexity. That's how that works. So if you want to know, if you have the meanings of students, want to retrieve their, for example, their grade, right? The function is we apply the hash value of the name, and then to find the index, corresponding index, and then we can find the value, find the grade. Okay. Second, cryptographic. Okay, so this is being, I think this is for hash function is using a domain a lot in this part. Okay, purpose, data integrity and authentication. Then using for password. Okay, so I'm not sure you guys designed the application, design like a credential to type the username and password, right? How to store the password. I remember like 10 years ago, I want to reset my password on my PNG account, professional engineer account. And they let me send the email. I sent. They give me my password, actual password. And I was shocked because at that time that password I was using a lot of places. Okay, so I was shocked how their PNG, the organization, developed this kind of application. Yeah, so you cannot do that. Okay, so this is easy to breaching. Okay, so on the password, you do password hashing. Okay, to hash the password stored into database. Even though your database is being compromised, okay, being stolen by someone, but they're hard to know what the actual password is. Okay. So password hashing we've been using, right? To store the hashing of the password inside the password itself. Okay. More secure, if you want to have the more secure, so they're using the salt, okay? Add some salt, several digits of the salt, either prefix or postfix, whatever, and then process hashing. Salt will be stored on a separate table for each of that. give them more security, right? Even though you find okay, even though you grab the database, you're able to revert back, but you still have a chance. It's okay. It's hard to guess, right? Which actually password is, right? Every sort are different. Okay, so all right. DDoS signatures. How DDoS signature work? So, for example, in the using a lot of on the military or communication. Okay, so for example, once I send a text message to someone, to a friend. Okay, how can we make sure? How can we make sure they send it securely? We can use what? We're leveraging the hash function, right? We'll be hash the message. Okay, encrypt the message, the content itself. Also, we have the two things. One called private key, one called public key. Okay, private key you install on your own device or on your local PC, and the people I want to send over, they have the public key. That being have agreement between. Okay, so once I send over the message to you, you use the public key to decrypt the message. Make sure that's from me. Okay, so and then they're able to view the message itself. That's what the DDoS signature works, how that works. They're also using what? A lot based on what? SSH. Have you worked on the SSH tunnel? Okay. To have remote access, also the gate, right? Gate have a similar mechanism, okay? To verify it. You have SSH key, right? You build SSH key. You already have the what? Private key and public key. For public key, you share into where? Share into the repo. Usually maybe in a GitLab, okay, GitHub, right? Any repository on the server. So you store the public key value there, and each time you do the get colon, okay, or push or fetch, you have a private key and they have public key. They can do in the verified. That's from you, okay, not from others. If you don't have the private key, you try to colon. If it's a private repo, you're unable to do that because you don't have a private key. Okay? Make sense? That's how that works. Okay, so message integrity check. So similar, but they are using what? They're using actually called the checksum to check whether in this message it's similar within the DDoS signatures, similar mechanism. Blockchain, okay, blockchain. Have you guys heard about blockchain? Okay, maybe 2 years ago, 2 or 3 years ago, during the pandemic, the Bitcoins, okay, the price is going up a lot, rapidly. So the blockchain becomes a very popular topic to discuss. The blockchain. How blockchain work? They're leveraging a lot of hashing as well. Okay, very quick introduction for blockchain. So blockchain they're using by block, okay, for block. Not like we discussed about the linked list, like a node, similar concept. They have a block. For block, they have a value. Okay, they have a value. They have a hashing itself to record this block. They also have the hashing on the pure block. They can link up together. So it means for each of the user, they can view and access the chain. Okay. So it means what? For example, if you want to make a transaction, okay, maybe you have 100 Bitcoin, right? You want to transfer 1 Bitcoin to others. Okay, so far, how we can do the transaction? We'll do transactions through the bank. Okay, you have a bank account, either e-transfer or wire transfer on the bank, but you have to go through the centralized database or centralized from bank. Bank is centralized organization. They manage all the transaction. But for the blockchain, they don't need. Okay, they don't need. So everyone have the, okay. Okay, bye. Okay, yeah, good luck. Good luck. Yeah. So every user they can access the chain. They provide the transparency. Okay, so they know what's going on in each blockchain. Okay, but they link together by what? By hashing. They're using the SHA 256. Okay, so the hashing function we just say. So it means what? It's hard to breaching, right? You want to break the chain, it's hard. Okay, but once a transaction makes through, right? For example, you have 100 Bitcoin, you want to transfer 1 Bitcoin to others. How that works? So, okay, I'm going to transfer the 1 Bitcoin from A to B. Okay, so you make a transfer on your chain. You need to create a new block into the chain. Okay, into the chain. You need to verify by all other users. Okay, so you have the over more than one Bitcoin in order to make a transfer successfully. And your second thing, you also make what? Make a proof of work. They call the proof of work. What called mining? This is a mining process called proof of work. Okay, to process that, and that's mainly for calculating the hashing. Okay, so it's using massive computing to calculate the hashing. Once you succeed, you add your block into the chain, and everyone to view and know what's going on. Okay, that's how roughly that works. But now it's being built based on the Bitcoin, like this kind of. They built a lot of the new kind of the way for the encrypted currency in Ethereum, right? So it's being after the Bitcoin, it's the second largest, right? Encrypted currency hub. Okay, there's something how the works, okay? How it works for using the blockchain. So the blockchain not only for Bitcoin, but also using for what? Using for, like, for example, for voting system. You also can use blockchain to develop a voting system, right? So the benefit is what? It's transparency and it's hard to hack. It's impossible to hack. No, cannot say 100% you are able to hack, but impossible to hack. Okay, so that's been using a lot, right? For security perspective, we're using hash into here. Okay, so the reason here is irreversible and collision resistant. Okay, so we have a feature for that. Third, data checksum and error detection. So the purpose is ensure the data is not corrupted. File integrity, right? Check. You're using the MD5 sum or SHA 256 sum. Network package and disk storage system. Have you guys ever using we call the BT to download the file from internet? Do you know what the BT? BitTorrent. Yeah. Okay. Yeah. Like when I was in university, maybe 20 years ago, the internet speed is not fast. When we download a file, like for example, a movie, right? Movie online, maybe 1 gig or some 500 megabytes. We have a download. There's no way you can view it online. We have a download and watch it. Okay, so we're using the BT, the software called BT. That still exists, the BitTorrent. So what they do here, they download the way they download is faster than you're just using the Microsoft download, right? So much faster, many times, 10 or 20 times faster. How it works? They cut the entire file, cut into pieces. Okay, a chunk. Okay, and then you download each of chunk at the same time. But here, okay, how do you verify? You finish this download? How do you verify after you chunk this file, the file not being damaged? Okay, so that's why they're using what? They're using hash to verify it, called the checksum. So for each of chunk, they created the .torrent file to record the value of the checksum for each chunk. And after you finish the download, the entire file, they have the what? they have the checksum. They have a torrent file. And then you put them together to verify it. Okay, to verify it. This is just how to verify whether the file is an integrated file or not, right? They have all other kind of way, because if the more people download, you have the more speed they have other kind of the schema to speed up the download, okay? So it's just a way to verify the file it's being integrated or not, okay? Not being interrupted, not being corrupted. Network package is similar. TCP/IP, right? When the TCP/IP doing the transmission from the internet, they also buy the block, okay? And then put them together. They need to make sure, okay, this is a message not being damaged, not being interrupted. They're using the checksum to verify it. If it's not same, not match, something wrong, they have to re-request again. Okay, doing re-request again. Okay, but TCP and TCP/IP is usually very stable compared to UDP protocol. I using UDP protocol on the hardware a while ago. UDP have a lot of errors, but the speed is really fast. Okay, just side of topic. Disk storage system, right? So they've been using for that as well, right? Disk storage. You want to have the partition, right? You want to do the partition on the disk. You make sure this, even though you do a partition, but the file not being show the damage, whether the file being damaged or not, you can to verify it. Okay, so that's for using hash function to verify it. Okay, so data checksum and error detection. So the reason is quicker verification of large data using a small hash value. Okay. Okay, data deduplication. Avoid storing the duplicate data. Okay. Avoid storing the okay, deduplicate. Avoid storing the duplicate data. So here though, once we create the backup system, right? Backup system. Usually we have a lot of content. It's same, right? Compare the purest version. If you guys are using version control, you know the majority of the code is same, just some are different. Okay, so the way they store here, we try to save the disk. Okay, what they do, they cut still by chunk. Okay, partition. Okay, based on how large a file they do in a chunk. Maybe they have the very large file, 1 gig of the file. They chunk 50 chunks. But when you do the backup, maybe 2 chunk is being updated. All others the same thing. We need to verify, okay, which is not being updated, which is being updated, which chunk is being updated, which chunk is being updated. So we're using what? Checksum to verify it. And then we just store the chunk being modified, store there. All others we don't store, we're just doing the link. Okay, we link them together, still able to reuse. So that's a way to can save a lot of disk. Okay, so similar on the cloud storage, right? Dropbox, Google Drive, and other stuff. They're also using like the repo. Okay, so of course for that. So they try to maximum to using the space. Okay, even though you store a lot of data, but actually it's not that case, right? So it's a lot of data, it's the same. Okay, compare with the hash value instead of 40 file instead of four files, right? To speed up speed and also to save the storage. Load balancing, distributed system. Did you have heard about load balancing? You heard about load balancing, right? When you go to the internet, go to a website, you have on the front end, before loading the front end, you have load balancing, right? To distribute all the requests. Okay, so let's go through this here though. Even distribute the task or data. You have a constant hashing, okay, to distribute the hashing like Redux, DynamoDB, and shared in database. Keep distribution stable even as node is add or remove. So here, how load balancing working here though? First, if you work on the cloud server, okay, on the cloud server, they have the server called load balance, okay, or DNS on the DNS, right? They have the sort of load balance that you require to do. Because they try to avoid, for example, they try to support massive requests. Okay, it's not just a single user using the application. Maybe turn the millions, right? Or millions or 10 millions, a lot of users like Google, they're trading cell requests for each of a day or seconds, right? So they can support that. They usually to distribute the application into multiple servers, okay? Into multiple servers. But they want to distribute all the requests into the different server. So that's how the load balancing works, okay? So because hash function, they have the evenly distribute. They leverage the hash function to build on this kind of build on these servers. Okay, so load balancing. Usually on the application being using a lot. Okay, on databasing also being using a lot as well. If you have the query, right? A lot of query happened instantly, like just second. Have massive requests on the query, right? To fetch the data, they try to distribute the request on the multiple server as well. Okay, so that's how they're leveraging the hash function to distribute or load balancing the request is what do here. Okay, there's a way, very traditional way, try to destroy your system, right? Use DDoS something, yeah. It's a massive request. Okay, keeping request. Right, so you DDoS. This is one of the. Okay, so subtopic, how to destroy the other's website. So, okay, so indexing and searching. Index and search we discussed about it before. Speed up searching, especially within a large database, right? And we're using hash-based indexing on database. Search large file over database. So fast lookup and filter than the linear or binary search because it have a big O of 1. We know the AVL tree, right? We talk about the indexing, right? Do you guys remember? Okay, because that was time comes to log n, right? But now it's log 1. Yeah. So if we just a single query, right? To search, for example, search a key, our user ID equal to what? Using what? Hash table. That's compare within the AVL tree, it's faster. But I mean, the different scenario have a different way to retrieve all the data. This is a good way for sure. But if you want to search a range of the data, AVL tree is better because they go through, right? Go through the certain of the range, compare within the hash table. So I believe on their like a low level of design, on their how to manage searching based on the query, what type of query you pass through, they process a different way of the search, right? So again, for interview question, how to speed up the search, you said doing the index. Okay. At back of the index, there are several ways to index the data. Okay. All right, okay. Randomization, fingerprint, okay, randomization. Create a unique identifier or simulate the randomize. Used for fingerprinting the document, detect the plagiarism or similarity, right? Randomize the algorithm. So the reason it's a quick detect the duplicate or near duplicate without comparing the full data. Okay, so this is a pretty straightforward, right? Concept. But question here though, in the software area, can we have the truly randomized? Can we create a truly randomized function in the software? Why?
It's all based off of the algorithm.
Based on the algorithm, right? So there's I cannot say impossible, but theoretically it's impossible. Create a true randomized. You will find the sort of what non-randomized case happened if you like try call the random function enough as many enough. Okay, so the way to do the truly randomized using the leveraging the hardware. Because the hardware, one of the hardware the way I heard about, they use entropy. Okay, entropy. You guys know entropy, right? Thermostatic entropy. You guys know entropy. How the molecule, the order. So every time, even though very close times are different, they leverage this to create the truly randomized. Okay, so this has been importantly like for some of the physical low-level research. Okay, for us it won't be touched much, right? Okay, yeah. Okay, game development and graphics. Also, the purpose to fast access the assets and scenes data. So they use for storing the game object data, caching the shaders and texture. So the reason is they enable the fast retrieval of the game data, texture, model, and sense node. So if you guys play the game, you know the texture, okay? Texture and the model. They are making the model, each of the scenes. But actually, that's a mass of data to create. If you're able to fast retrieval, and you make your game more smooth to play, right? For example, the pathfinding, something like a shooting game, maybe a while ago shooting game, right? You're shooting a lot of people play together. They have the 3D map on there. You want to find the path, okay? But in each of paths, they have 3D objects there. But actually, this is using a lot of the computing power to simulate this kind of thing. But you create a model there. How do you retrieval? Once you go someplace and retrieval this kind of model, retrieval kind of sense, and the textures. So that's how this using the hash function to leverage the hash function to retrieval this kind of information. Okay, so it's making gaming experience it's better. Okay. I hope in the future some of you can develop some game. Game is hard. Game is really hard. Okay, geometric hashing. Okay, so it's a shape recognition and matching. So this been using a lot on the AI, like the image recognition, pattern recognition. They use some of the function is using hashing. Okay, so the property effectively recognizes the geometric shape or pattern. Object, face 3D model, as maybe, so rotate, translate, scale, or partially occultated. Use the object recognition in 2D and 3D image. Medical image matching, right, for tumors and bones. So like in the AI, for image recognition, is I think 5 years ago, 5 or 10 years ago, it's a bit of challenge to recognize, because the image they can rotate, they can just maybe a part of the image, but how do you able to what to here they're using the hash relative position of the features, able to really to pattern recognize, right, and it'll be a challenge. So also can match sharp quick, even though it's rotation, translation, and scaling, occultation, right? So that's a hash table being used on the AI world, traditional AI world. Okay, traditional AI world. Okay, let's discuss about the hash table. A hash table is a data structures that map the key to a value using the hash function to compute the index into an array of buckets. So they provide a fast access. The average key is big O of 1 for data to retrieve data through the key. Okay. Similar dictionary in Python, hash map, in hash map, the built-in function hash map in Java, or unsorted map in C++. This is a hash table, built-in hash table library being used in a different language. Component of hash table. They usually have a key, right? In the dictionary on Python, and the hash map or the map, unsorted map in C++, you have the key. You need to define the key, right? On the key, you need to define the value, which is associated with this key. And you have the hash function, okay? Hash function to convert what? Convert a key into the index, okay? Into index. And a bucket or slot for each position in array, which you store the key value pair, okay? Component of the is the same. Common operation. Okay, common operation. We have an insert, so you can insert a key with a value, right? Insert. You have to insert a key and with a value. So the average is a big O of 1. Worst scenario, big O of n. The worst scenario. If you building the hash table, it's not a perfect hash table. The complexity may be turned into the big O of n. Okay, big O of n. So it means what manipulation happened. Okay, the worst scenario you have the entire is all the collision. That's not a speed up. Won't be speed up your searching, right? Okay. You get its get the value. You pass a key and you get its value, right? To retrieve the value associated with the key. So how that works? You in the key you press a hash function. Of the hash function you get the index value, and on the index value you can find the corresponding value of this key. Delayed, remove the key and associated value, okay, and the contents to verify whether the key exists into this table or not. Okay, that's all big O of 1. So it's very, very fast, okay, very, very fast. Compare within the linear data structure, also the compare within the tree structure, all right? Okay, so hash table here in the Python, as we know, we are using a dic, right? Dictionary, also using a set. In the Java, we're using the hash map or hash set. C++, we have the unordered map, unordered set. This is the built-in function in this programming language.